In software engineering interviews, there is a classic question. What happens when you type a URL into browser and hit enter? It tests whether you understand the full stack: DNS resolution, TCP handshake, TLS, HTTP request, server routing, rendering pipeline. If you can walk through the entire journey, you understand the web. In the AI era, I think the new version of the question is this. What happens when you type a prompt into Claude Code and hit enter? Most developers use Claude Code or a similar AI coding tool every day, but very few can explain what actually happens between pressing enter and seeing the response. There is system prompt assembly, model routing, the Agentic Loop, tool execution, and context compaction, an entire orchestration engine running behind the scenes. Today I am going to trace every single step of that journey, so the next time someone asks you that question, you'll nail it. Let's start with something simple. You type fix the login bug and press enter. Your prompt doesn't go straight to Claude, it actually passes through 6 layers before it ever reaches the model. First, the terminal input handler captures your text. Then the CLI parser processes arguments, flags, and session state, followed by the session manager checking whether to resume an existing session or start a new one. After that, the context loader kicks in and loads your Claude.md files, skills, memory files, and MCP server definitions. Then the system prompt assembler composes everything into one massive prompt, and finally, the API request builder packages the entire payload for the API call. That fifth step, the system prompt assembly, is where it gets really interesting. Claude Code's system prompt is not a single block of text. It's modular, made up of approximately 110 discrete components that get assembled dynamically. And that's before you've said a single word. Here's what those components include. Core agent instructions, which is the "you are the Claude Code" personality and rules. Tool definitions for 18 built-in tools. Sub-agent prompts for the plan, explore, and general-purpose agents. Safety and security guidelines. Context management rules. Your Claude.md content from project, user, and local levels. MCP server tool names, skill descriptions, permission rules, and various formatters, reminders, and utilities. The base system prompt is relatively compact, around 10 to 15,000 tokens. But once you add MCP servers, skills, and custom Claude.md files, the total system overhead can grow to tens of thousands of tokens. In heavy configurations with many MCP servers and plugins, it can consume a significant portion of your context window. Once everything is assembled, Claude Code builds the actual API request, and here's what the payload looks. The system field is an array of text blocks, one per component, while the messages array contains the full conversation history. On the first turn, it's your prompt, but by turn 10, it might be 50,000 tokens of back and forth. This payload gets sent to Entropic's API, which handles streaming, token counting, and error recovery, and then tokens start flowing back in real time. This is the heart of Claude Code. Everything else is orchestration around this single mechanism. The Agentic Loop is essentially a while loop, and the pseudocode looks like this. That's really all there is to it. The entire agentic behavior of Claude Code comes from this loop. Call the model, and if it responds with text, you are done. But if it responds with a tool call, you execute the tool, feed the results back, and loop again. The decision between text and tool call is encoded in the response stop reason field. When Claude returns end turn, the response contains text for the user, and when it returns tool use, the response contains a structured tool call with the name and parameters. Here's what that looks like in practice. You ask Claude to fix the login bug, and Claude's first response is a tool call to read login. The file contents come back, Claude analyzes them, decides it needs more context, and calls grep to search for related functions. Those results come back, Claude chains the information together, identifies the bug, and calls edit to fix the file. Then it calls bash to run npm test, tests pass, and Claude returns an end turn response explaining what it fixed. Each cycle through the loop is one API call, and a typical task might take 5 to 15 cycles. A complex refactor could easily take 30 or more. The loop has 5 termination conditions. Claude returns end turn with the text response. The maximum turn limit is reached if you've set one with the max turns flag. The user cancels with Ctrl+C, the budget is exceeded if you've set a spending cap with max budget USD, or a fatal error like error failure or API outage. There is one more detail worth mentioning. Claude Code implements real-time steering through an asynchronous message queue. When the agent is actively processing, new user input is buffered and injected into the loop once the current action completes. So if you type while Claude is working, your message is queued and addressed in the next turn. You can also interrupt Claude mid-task. It will adjust its approach, though it won't necessarily stop the current tool execution immediately. That's why steering Claude feels smooth rather than destructive. When Claude decides to use a tool, the call goes through a multi-step pipeline. First, the tool use block is parsed and validated. That includes the tool name, ID, and parameters. Then a permission check runs to verify whether the user's permission mode allows this tool. After that, any registered pre-tool use hooks fire and can potentially block execution. Then the tool actually executes. Read reads the file, bash runs the command, edit modifies the code. Once that's done, post-tool use hooks fire for formatting or validation, and finally the result is packaged as a structured tool result and fed back into the conversation. Claude Code ships with 18 built-in tools organized by capability. For file operations there is read, write, edit, notebook edit, and glob. For search there is grep and web search. For execution there is bash, which covers everything from git commands to running test suites. For web access there is webfetch for parsing pages. And for orchestration there is task for spawning sub-agents, ask user questions for clarifying with the user, and skill for invoking custom workflows, plus several more for plan mode, team coordination, and internal utilities. There are also optional IDE integration tools like getDiagnostics for surfacing type errors and warnings, but those depend on your IDE setup. The permission system controls all of this. You can configure modes from default, which asks for approval, all the way to the dangerously skip permissions flag, which skips all permission prompts. You can also set granular rules that allow specific bash commands like npm test while blocking dangerous ones like rm-rf. Here is something most people don't realize. Not all operations use the same model. Claude Code routes requests to different models based on your subscription, and your tier determines the default. Opus for Max and Team Premium subscribers, Sonnet for Pro and Team Standard. But not everything runs on your main model. Background operations like conversation summarization and housekeeping tasks get handled by Haiku automatically, and the built-in Explorer subagent also uses Haiku for fast read-only code-based searching. Haiku is significantly cheaper, about 3 times less than Sonnet and 5 times less than Opus, so this keeps costs down without affecting your main workflow. You can also switch models naturally with the model command, and if you want to optimize cost, you can set model Opus plan in your settings file. This uses Opus for planning and architectural analysis, then automatically switches to Sonnet for execution. Deep thinking where it matters, fast implementation where it doesn't. Opus also supports effort levels. High is the default for maximum capability. You can switch to medium or low for faster, cheaper responses, or max for the deepest reasoning on harder problems. Claude Code typically uses a 20,000 token context window, though newer models like Opus 4.6 and Sonnet 4.6 support up to 1 million tokens. Going beyond 20k is possible, but it will cost you more, and here is how that space is allocated. The system prompt overhead varies depending on your configuration. A minimal setup might use 10 to 15,000 tokens, while a heavy setup with multiple MCP servers and plugins could use significantly more. Either way, the rest is available for your conversation, and there is also a compaction buffer of about 33,000 tokens reserved as a safety margin. As you work, every tool call and result consumes context. A file read might be 500 tokens, a bash output could be 2000, and after 10 to 15 cycles through the Agentic Loop, you've easily used 30,000 to 50,000 tokens of conversation space. When context usage hits approximately 83.5% of the 20k limit, that's around 167,000 tokens, auto-compaction triggers, and here's what happens. Claude analyzes the conversation history and all tool outputs get removed. The verbose file reads from early exploration, bash outputs from failed attempts. The conversation gets summarized into a compact representation Something like user asked for a login fixed, found issue in session validation, edited 3 files, all tests pass. Compression boundaries are marked and then a fresh API call is made with the compacted context. You see a brief context compacted message, but the conversation continues uninterrupted. Post-compaction, context usage drops back to around 60%, giving you room to keep working. What survives compaction? Your current task, recent context, recent instructions, and key decisions. What gets dropped first? Verbose tool outputs from early exploration, detailed error messages from initial failures, and exploratory calls that led nowhere. Here's the practical takeaway. Put persistent instructions in Claude.md, not in conversation. Claude.md reloads every session while conversation contexts get compacted away. When the main agent needs help with a complex subtask, it delegates to sub-agents. Sub-agents are separate Claude Code instances and each one gets its own isolated context window, a custom system prompt, and restricted tool access. They run independently and return results to the main conversation. Claude Code ships with 3 built-in sub-agents. Explore uses Haiku with read-only tools for fast code-based searching. Plan inherits the parent's model with read-only access for architectural analysis. And General Purpose inherits everything and can use tools for complex multi-step work. You can also define custom sub-agents by dropping a markdown file in .claude/agents with a name, description, tool restrictions, and specialized instructions. Claude recognizes when a task matches the description and delegates automatically. The key benefit here is context isolation. The sub-agent's work, all the file reads, searches, and analysis stays in its own context, and only the final result comes back to the main conversation. This prevents context bloat in long-running sessions. Multiple sub-agents can also run in parallel on different tasks. One researching the code base, another reviewing code quality, a third generating tests, each with a fresh context window. 3 more mechanisms complete the picture, and I'll cover them quickly. Hooks are scripts that intercept the agentic loop at specific lifecycle points, before a tool runs, after it completes, or when a session starts or ends. A pre-tool hook can block dangerous commands by returning exit code to, while a post-tool hook can format output or log actions. They are configured as shell scripts that receive JSON on standard input. Skills are markdown files that extend Claude with domain knowledge. Their descriptions load at session start, but the full content only loads when a skill is actually invoked. The exclamation mark prefix executes bash commands inside skills for dynamic context. So a skill can include exclamation mark get diff, and the actual diff gets injected at invocation time. Session persistence saved everything to disk. The transcript as JSON-L, task list as JSON, and file checkpoints before every edit. The --resume flag restores a previous session, and every file edit creates a checkpoint. If you press escape twice, it opens the rewind menu where you can choose to revert your code, conversation, or both to a previous checkpoint. Edits made through Claude tools are reversible, but changes from bash commands are not. So that's the full journey. You press enter and your prompt passes through 6 layers of processing. A modular system prompt gets assembled from 110 plus components. The payload hits the API and the agentic loop takes over. Cycling through observe, decide, act, observe as many times as needed. Tools execute through a multi-step pipeline with permission checks and hooks, while models get routed intelligently with Haiku for background tasks and Opus or Sonnet for reasoning. Context gets managed with automatic compaction, sub-agents handle complex subtasks in isolated contexts, and the whole system is extensible through hooks, skills, and custom agents. Claude Code is not just a chat box with the file access, it's a full orchestration engine, and understanding how it works makes you a better user of it. If you found this useful, hit like and subscribe for more content on AI development tools. Each of these topics deserves its own dedicated video, so let me know in the comments which one you'd like me to explore in depth, whether that's the agentic loop, context compaction, sub-agent, or anything else we covered today. And now that you know how much work goes into a single keystroke, you might want to keep your cat away from the keyboard.